All right, welcome to the formulaic approach. Now I will continue the video on redox reaction. I'll make this video with the former one that I shot last night. So please do well to stick till the end. I promise you that you will understand balancing redox reaction. In fact, I compiled some questions just this evening so that I can use to teach you. Okay? Now, in order to balance, well, first, what is redox reaction? That is reduction and oxidation reaction. I told you that they happen simultaneously in a chemical reaction. They happen simultaneously. Now, and they are reverse of each other. Now, the definitions I give you many definitions. That is the loss of, the oxidation is the gain of oxygen, while reduction is the loss of oxygen. Oxidation is also the gain of hydrogen, and reduction is the oxidation is the loss of hydrogen, while reduction is the gain of hydrogen. Did you see? They are opposites, right? When oxygen is gained, that is oxidation. When hydrogen is lost, that is still oxidation. When hydrogen is gained, that is reduction. When oxygen is lost, that is reduction. When there's increase in oxidation, about oxidation. When there's decrease in oxidation, about oxidation. Now the last one I gave you, which was the final definition, was loss of electron is oxidation and gain of electron is reduction. All right. Now, in order to balance redox reactions, you must first know how to determine the species that we have. Now, if the species that undergoes oxidation, is called the reducing agent, while the species that undergoes reduction, so the oxidation will happen to the reducing agent, while reduction will happen to the oxidizing agent. Let me take that again. Oxidation happens to the reducing agent, or that is, the reducing agent is the one that is being oxidized, while the oxidizing agent is the one that is being reduced. Now let me give you an example that I gave you yesterday. For example, if I have magnesium and HCl. Now, magnesium and HCl want to react together. Magnesium will displace hydrogen, right? And then it will become MgCl2 plus H. So from here to here, and from here to here, from here to here is oxidation. How do I know that? Because another definition that I gave you yesterday under oxidation reduction is that the gain of electronegative elements, scientists found out, is also called oxidation, while the loss of electronegative elements is reduction. So you see from here to here, electronegative elements, chlorine was lost, and from here to here, chlorine was gained. So that's oxidation, here reduction. Now listen, this is my point. Your reducing agent and oxidizing agent, you can only check them from here, from reactant side only, not from product side. I've seen JAM questions, GPEP questions where they will say which one is oxidizing agent, which one is reducing agent, and they will give options from the product side. Those two options from the product side will be wrong. The oxidizing agents and reducing agents are checked from the reactants. Now, this guy that is being oxidized is the guy that is called the reducing agent. Why? Because it is the guy that helped in reducing this guy. It helped in reducing this guy by stripping this guy off of its electronegative elements. Does that make sense? I mean, it's supposed to be hydrogen gas. I'm sorry. So let me take that again. This guy is the reducing agent because it was the one that was oxidized. So remember, the oxidizing agent is always what? The reducing agent is always the one that is being oxidized, and the oxidizing agent is the one that is being reduced. So this guy that is being reduced here helped in oxidizing this guy. So it's the oxidizing agent. Does that make sense now? So it's the one undergoing reduction. Think of it as someone that is given. So the person that is given is the one undergoing reduction because something is being removed from him. But the person is given to is called the person that is reducing. He is the reducing agent because it's the one reducing this person, but it's the one that is being oxidized because it's the one that is being added onto. Does that make sense? All right. So now, what are the rules for balancing chemical equation? The first thing you have to do is to identify the species that is being oxidized. The first thing is, if I give you a full equation, split the equation, the overall equation, into half reactions. Now, what are the half reactions in this case? We have the oxidation half reaction and the reduction half reaction. Now, you have reactions. The oxidation half reaction, for you to be sure that it is oxidation half reaction, you will notice that at the end of the day, use this ORL. Use it to remember this. That at the end of the day, if you are correct, that if you have picked the right equation for your oxidation half reaction, then at the end of the day, this guy, the oxidation of your electron, when you be adding your electron will be added to the right side, the right hand side of your equation. That is the product side, this side of the equation. But for your reduction half reaction, to be sure that it is the correct one you picked, the correct equation you picked for reduction half reaction, you find out at the end of the day that your electron was added to the left side. Now, why did I give you this? Oxidation, right hand side, reduction, left hand side. Oxidation, right hand side, reduction, left hand side. So that's how you know whether you picked the right set of species as oxidation half reaction and reduction half reaction. So once you are able to split the overall reaction into half reactions, the second step you have to take is to now balance atomically. And the sequence is order elements first, then oxygen last. Do you understand? Followed by oxygen. Oxygen is always last. Balance other elements first, then oxygen last. Now, how should you now balance oxygen? Balance oxygen, that's the next step now. Balance oxygen using water. Is that okay? Now, by balancing oxygen with water, you will find out that you would have introduced hydrogen. So you will now balance hydrogen using protons. Exactly. You use protons to balance hydrogen. Now, after doing that, you now balance ionically. That is, you balance the charges. So what's the total charge on this side? What's the total charge on the other side? Now, how do you balance charges? You balance charges by adding electrons to the side that has the highest charge. Add electron to the side with the highest charge. Now, you see, you might be thinking that, do I have to memorize this? Don't worry. But the moment you see me solve, you see that I didn't memorize anything. It becomes part of you. You know what the next step, because the steps they are similar, especially when you use the technique I'm going to be teaching you. Now, all of this is for balancing in acidic medium. If you now want to balance in basic medium, so the way we do it is that I teach my students to first balance in acidic medium before balancing in basic medium. So in basic media, the way you balance in basic media is you will add equal amount of OH minus as H plus to both sides of the equation. What does that mean? It means that the number of H plus, now how do you know it's acidic? You will know it's acidic when it ends up with H plus being in either side of the reaction. H plus is going to end up being in your reaction. So, to now balance in a basic medium, if I have 4H plus, for example, you should add 4H minus to both sides. You must not add to just one side. Add it to both sides so that your equation will be balanced. You add it to both sides of the reaction. So, for example, where you had H plus before, By the time you add 4OH minus, because you must add equal number of the same number, is that okay? What you will get is 4 water too. 4 water. Because if I break down water, what will I have? I will have H plus OH minus, right? So this is 1 water. 1H plus 1 OH minus is 1 water. So 4H plus 4 OH minus will give me 4H2O2. 10H plus 10 OH minus will give you what? 10H2O2. H2O. Is that clear? Good. So let's follow this reaction, these steps to balance a half reaction. Let me start with a half reaction for you. So let's say, for example, in this case, we have split a reaction into half reactions, and we have something like, give me something like MnO4 minus to give Mn2 plus. So let's say we are giving this half reaction. Now, how do you balance this? How do you balance this? Now, look at this. We have to first balance atomically. That is, make sure you balance the other atoms before oxygen. So now, check. How many manganese do we have here? This manganese is 1 here. This guy here is the charge. Never touch the charge when you are balancing the atom. Never touch the charge. So here, this manganese is 1. Here, manganese is also 1. It's not 2. This 2 above is the charge, not the atoms. So I have 1 manganese, 1 manganese. So it is balanced. Then I go to oxygen. How many oxygens do I have here? 4 oxygen. Now, to balance the oxygens, I will use water to balance oxygen. I cannot go and add oxygen because the reaction is taking place inside water. Exactly. So some oxygen will balance it by itself. Some water will balance oxygen by itself. So how much water do I need to balance this? You will add equal amount of oxygen as you have of water. No, you have equal amount of water as you have of oxygen. I have how many oxygen here? 4 oxygen. I will add 4 water to the opposite side because this is the side I need oxygen, right? So I'll go there and go and add 4 water because by adding 4 water, I have added 4 oxygen. Does that make sense to you? I'll repeat. Before I repeat, there's something that I thought I should add to that. Now, H2O, the species that you can add to your redox reaction include H2O, H plus, electron, OH minus. Other than this, you can't add anything else. You can add water, H plus, OH minus, and electron. Other than this, you can't add anything else by yourself. You cannot manufacture anything else. All right. So because your reaction is taking place in water, in aqueous solution, so it is balancing itself. That's what it is. But we want to balance it when we give you the ionic form. That's what we're trying to do. Do you understand now? Right. So we want to know how many species we need to balance each side. Let's go again. We said manganese is 1, manganese is 1 here. Oxygen is 4. To balance oxygen, we add 4 water, equal amount of oxygen as we have here. Equal amount of water as we have oxygen here. As we have 4 oxygen here. We have 4 oxygen, we add 4 water. But you will notice that by adding water here, we have added a new species, which is what? Hydrogen. You see? After balancing with water, you have added hydrogen. So you need to balance hydrogen using what? Protons. So you come here and add, how many protons do you need to balance the hydrogen here? You have added 8 hydrogens here. You will add 8 protons. Is that clear? Good. I hope that's clear. The step is the same. Balance the first species, metal in this case, then balance oxygen on the other side, then come back and balance hydrogen. Is it clear? So now, by the time we check again, you will see that it is now atomically balanced. The next step is to balance ionically. What do you mean by balancing ionically? You balance the charges. What's the total charge here now? This is what you have to listen carefully here. The total charge here is -1. What's the total charge on this guy? It is +1. Remember I told you yesterday that if at the beginning, because I'm posting it together. At the beginning, but I shot that video yesterday when there was power outage. My point is that I told you yesterday that when there is no charge on an atom or a molecule or a compound, that atom is said to have zero charge, ground state charge. So, but when you have a charge here, then there is a charge. Make sense? So let's go again. What's total charge on this guy? You can see -1 here. There is no number here, so we'll write -1. But look at H plus. H plus has plus charge here, right? But it is 8 of them. That means that I have the first H plus, second H plus, third H plus, up to 8 H pluses. So that is +1, +1, +1, +1. In 8 places, that is +8. Is it clear? It means that the total charge on this side of the reaction, is 7 plus 7 plus -1 plus 8 is +7, right? Good. So since I have my total charge here to be +7, so I put that here +7. Then I come here. What's the total charge on this side? Here +2. On this guy 0. So here is +2. Now the guy now said, the instruction now says I should add electron to the side with the highest charge. Now which side is with the highest charge? 0 plus 2. Here total gave us 7. So this charge is with the highest charge. So I'm going to add electrons. Now how many electrons will I add? I want to make this side side equal to this side in the number of charges. Total charge here is 7. So I will add how many electrons to make it 5? To make it 2 rather. I will add 5 electrons. Now keep in mind that I am not subtracting electrons, I'm adding electrons, because electrons will eventually reduce the number of charge. Because electron is negative charge, that will be 7 plus -5. That's 7 minus 5, and that is 2. Do you understand now? So we always add electrons, we are not subtracting electrons. Is that okay? In case that is confusing you, that's why I needed to say that. Alright, so now I will add 5 electrons. So I'll come here and say plus 5 electrons. So it means that you see that you need to leave space. You need to leave space so that it can contain everything you want to write. So the balanced half reaction I have here is MnO4 minus plus 8H plus 5E minus to give Mn2 plus 4H2O. Does this make sense? So if you check this out, you'll see that it is balanced both atomically and ionically. So this is the balanced half reaction, not the full reaction. I'll give you one more half reaction, then we'll go to balancing full reactions. Say I have 1 Mn here, 1 Mn here, correct. 8H is here. How many H is here? 2 times 4, 8. Now, oxygen 4 oxygen. Good. So atomically, the atoms are balanced on both sides. Let's check the charge. Here, -1 plus 8 minus 5. What would that be? Plus 2, right? -1 plus 8, that's 7 plus -5 is 2. You come here, the charge is also plus 2. You see that's balanced, right? Good. Now let me take one more. Let me give you something like this. SO4 minus. This was the one I showed you in the example I gave you. No, let me use another one. Let me use something like that. So now let me ask you first, before we go to this one. Let me use this. Before we go to this, what reaction is this? What half reaction is this? Is this oxidation half reaction or reduction half reaction? What you check is where the electron is added. The electron is added to the left. So what would this be? This would be reduction half reaction. Reduction half reaction. Oxidation half reaction, electron will be added to the right. Reduction half reaction, electron will be added to the left. Is it clear? And that makes sense. The reaction was this to this. From here to here, you see that there is a loss of oxygen. And what's loss of oxygen? Reduction. Do you see it all add up now? It all adds up. It all adds up. Alright, let's go now. The next guy, SO4 2 minus, and is going to SO2. Now, how do we balance? Balance the first element, sulfur. How many sulfur do we have here? 1. How many sulfur do we have here? 1. Balanced. How many oxygens do we have here? 4. How many oxygens? Don't come and add this charge or this charge. How many oxygens do we have here? 2. So this side is 2 more than this. So we'll come and add 2 more here. But 2 what? 2 water. Remember, it is water we use to balance oxygen. So by adding 2 water here, we now have 2 oxygens more. But by adding water, we have also introduced hydrogen on that side. So we must come here and balance that hydrogen with 2. How many hydrogen do we have? Did we have 4? That will be 4H plus. Do you understand now? Let me take it again. S was 1, S was 1. O was 4 here. I mean, O is 4, it's still 4. Right? O is 4 here. O is 2 here. Now we need to balance it because we have 4 here, we have 2 here, we need 2 more here. So we add 2 water to this side. So the 2 water we add to this side, we'll have introduced 2 oxygens that we need. But of course, we have also introduced a strange guy, hydrogen. So we'll come back and add the strange guy here. 4, because it's 4 here, 2 times 2, 4. Here, 4H plus. Is that clear? By doing that, it's now balanced atomically. Let's now balance ionically. Let's balance the charges. Now, what's the total charge here? Here I have minus 2. Here, plus 4. Here, 0. Here, 0. So here, total charge is plus 2. So which place has the highest charge? This side. So which side are we adding electrons to? This side. Do you understand now? Now, how many electrons do we need to add to 2? To plus 2 to give us 0. That will be 2. God bless you. 2 electrons. 2 electrons. So I'll come here and add 2E minus. So by so doing, I have balanced this half reaction. I have balanced this half reaction. Now, I'll check my textbook, my book where I compiled some questions now. I will now solve a reduction, I will now solve you a full redox reaction, okay? There's a fine one here. It says Cr2O7 2 minus plus H2C2O4 C2O4 plus Cr3 plus CO2. Don't worry, after balancing this in acidic medium, I'll show you how to finish it in basic medium. I told you to balance in basic medium with this method, you first go acidic, then you now go basic. Exactly. Now look at what I'll do. The first thing I want to do is to separate which one is oxidation, which one is reduction of reaction. Here you also see that this is a reduction of reaction, right? Because electrons are added to the left hand side. Now for this one, sorry, this is arrow, please. For this one, which one from here to here? How do I identify the species? See, chromium is here. I'll just draw it to the next chromium. I can't draw this to this because there's no carbon here. So it's from here to here I will draw. Then I will draw from here to here. So this, from here to here, there is a loss of oxygen, right? So that's reduction. So this will be our reduction reaction. Then that means that this side to this side is our oxidation reaction. Is it clear? If this is reduction here, then this guy will be called the oxidizing agent. If reduction happened to it. Since this is oxidation here, then this guy will be called oxidation half reaction. I hope that is clear. Alright, then so we can now start with anyone. I told my students that they should separate. So let's take the reduction half reaction first. Always separate it to make your work neat. See, now I'm leaving space because I might add things, okay? Then Cr3 plus. So I'll write my oxidation half reaction later. Let me first balance my reduction half reaction. Now you will see that chromium is here. How many chromium do we have here? We have 2. How many chromium do we have here atomically? 1. So we add 2 at the back to make it balance. Is that clear? You know we had 1 initially. It's 2 here. We put 2 here to make this balance. Balance now. How many oxygen do we have here? 7. How many do we have on that side? 0. We add what? 7 water. You got it. 7 water, because it is always water we use to balance oxygen. Remember. Okay? All right. By adding 7 water, we have introduced a new species. And what is that species? Hydrogen. How many hydrogens did we introduce? 14. So we'll come back here and balance that with what? 14 protons too. 14H plus. Remember, proton is H plus. H plus is proton. So this is now balanced atomically. You can check. It's balanced atomically. Then you can now go balancing ionically. How do we now balance ionically? What's total charge here? There's no number here. That's 1 times the charge here. That's minus 2. Plus, plus 1 times 14 is plus 14. So we have 14 here. So plus minus 2 plus 14, that's 14 minus 2. That's 12, plus 12 here. What's the total charge on this side? We have plus 3 here times 2. That's plus 6. Here 0. So total charge here on this side is plus 6. On this side is plus 12. So where are we adding electrons to? Remember, add electrons to the side with the highest number of charge. Which side has the highest number of charge? This side. So, and that validates it. I told you reduction of reaction, you add the electrons to the left. So plus, how many electrons are we going to add now? To give us 6. That will be plus 6 electrons. Is that okay? Because plus 6 electrons will be minus 6. So plus 12 minus 6 is plus 6. Is that clear now? So we'll add 6 electrons here. Now, there was something I was supposed to tell you here before. Now, after, so our rule is not complete yet. Our rule is not complete yet. We have to add something more. I will show you what we should add. So this is our balanced reduction of reaction. Let's go to balancing the oxidation of reaction. From here to that place is our oxidation of reaction. We have H2C2O4 going to CO2. Now as it is, how many carbons do you have here? 2. How many carbons do you have here? 2. So we add 2. Is that okay? By adding 2, 2 times 2 has given us 4 oxygen, now balanced. Hydrogen here is 2. No hydrogen here at all. What do we use to balance hydrogen? What H plus. How many do we have? 2. 2H plus. Is that clear? You see that the step is, now the step changed a little here because we are not balancing oxygen. So we didn't need to add water. Is it clear? Good. So in this place, let's now see this balance. 2H, 2H, 2Cs, 2Cs, 4 O's, 4 O's, balanced atomically. Now let's check the charge. What's total charge here? 0. What's total charge here? 2 plus 2. So we'll come and add 2 electrons. By adding 2 electrons, everywhere there becomes 0. Does that make sense? Now, here is the step that we need to, before you can write your overall complete reaction, you need to take this step, which I did not add. Now add it. That you should cancel out species that appear equal on both sides. One thing you must first do is this. Make sure that electrons does not appear in your overall reaction. So we must try to cancel out electrons. We must endeavor to cancel out electrons. How do we cancel out electrons? First, make them equal on both sides, in both equations. Now, how do we make them equal in both equations? How many electrons do we have here? We have 6. Now, how many electrons do we have here? Make sure your target is that electron. We have 2 electrons here. How do we make it equal to 6? We'll come and multiply this equation here. We'll multiply it by 3. Now you now ask me, what do we use to multiply here? We don't need to multiply it with anything, by anything. Why? Because it's 6 and 2 can go to 6. Had it be to a 5 now, that 2 cannot go to 5, you now multiply this equation, you multiply by that, you multiply, had it be it was 5 for example, we know it's 6, so, but if it's a 5 now, we multiply this equation by 2 and multiply this one by 5 to make them equal. Is that clear? Good. When now it's 6, 2 can become 6 by just multiplying by 3. Isn't it? So this, our oxidation reaction becomes 3H2C2O4 to give 3 times this, 6CO2 plus 3 times 2, 6H plus 3 times that, plus 6 electrons. Now, I can cancel out directly here, but I don't want to. I want you to see the broad equation so that you know what I am cancelling. you'll be able to understand what I'm cancelling and why I'm cancelling it. So now let's write the overall reaction with all the things that are there. You notice our two reactions here. First this one and the second one. This one has changed, has been modified. It was modified to this. So we'll write it in the format we were given. See the format we were given. Cl2 should come first. This is reactant side. So I'm writing reactant side and reactant side together. So let me write this first. That will be Cr2O7 minus plus 14H plus. Now actually I should not write the 14H plus next, but for the purpose so that it do not confuse you, I want to write it next. I should write the species that are given first before I write the species that I added. So I should write this first, then this next. That's the way you should do it. But either way you arrange it, you'll still get the same answer. So plus 48 plus, then plus 6 electrons, then plus this guy, 3H2C2O4. Makes sense? Then to give, so we have finished reactant side. Let's go to product side. Product side, we have this plus water, 2Cr3 plus 7H2O plus this side, 6CO2 plus 6H plus then plus 6 electrons. So you now see here that this our reaction has electron on this side, electron on this side. So let's cancel them out. 6 electrons cancel 6 electrons. But remember that instruction I gave you said we should cancel out species that appear equal on both sides. Cr2O7 is not repeating itself here, no. But you see that the species you added repeats itself. For example, for hydrogen protons repeat themselves here. We have 14 here, we have 6 here. So we'll cancel 6 out of here. We'll come and cancel 6 out of here to remain 8H plus. Is that clear? I think there was water here. Let's say we added like 2 water, 2H2 here, for example. We'll cancel 2 water here. Come and cancel 2 out of here, which remains 5. Is that clear? Good. So our overall balance equation becomes Cr2O7 minus plus 8H plus 3H2C2O4 to give 2Cr3 plus 7H2O plus 6CO2. And this is the balanced reaction. You can check, you see it's balanced both by charge and by atom. I'll solve only one more question because I have a class now. And we'll call it a day. Now, to balance this, let me show you now. If you want to balance this in basic, it's very simple. No, this is it. Reach out to me. I'll show you, I'll give you questions. I can give you questions on balancing redox reaction. I might solve other questions later. Is that okay? But so that will be it for this video. Let me now show you how to balance in basic medium. If it were in basic medium, this is correct now for acidic medium. If the question says to balance in basic medium, very simple. Just go one more step. After balancing in acidic medium, add equal amount of OH minus as H plus to both sides. How many H plus do you have inside this reaction? We have it on this side, and how many is it? 8. So come and add plus 8 OH to this side, and to that side too, plus 8 OH minus. So on this side, this thing will turn to water here. So it will now become Cr2O7 minus plus this gives us 8 water. The amount, the number is just what you write back, but now in water. Then plus 3H2C2O4 to give 2Cr3 plus 7H2O plus 6CO2 plus 8OH minus. OH minus. So you see now that water is not appearing here and here, right? Cancel 7 water, cancel 7 to remain 1 water. So our final answer becomes, so you have to be patient, okay? Because you have to write and write and write. So we have Cr2O7 minus plus H2O plus The way we are supposed to write this is actually, let's write this first. That will be 3H2C2O4 plus H2O to give 2Cr3 plus 6CO2 plus 8OH minus. And this is the balanced balanced redox reaction in basic medium. Now you need questions. I have like 50 questions on this. So it's from simple to hard. I'll still make another video on balancing some of them. Or what we do is reach out to me. I'll send you the questions. If you cannot solve them, then I'll make a video on solving them as corrections. Do what to subscribe to the channel. God bless you as you do so. Amen.